All right, welcome back, everybody. So today's lesson, we're going to learn a little bit about particles, sediments, and how streams erode them. So first, let's take a look at this picture at the bottom. Talks about different sphericity and different rounded particles, and you can actually see people, take note of this stuff. Particles can have high sphericities, that means they're kind of round, or they can have low sphericities, kind of oblong. Then you can also look on the far right-hand side of this and see that those high sphericity particles can actually have their edges broken off and become rounded, well-rounded. But you can also have well-rounded particles that are not so spherical. And so just, be mindful of the fact that this stuff actually does matter. People do keep track of this. Now, as far as the green notes go here, particles that are eroded by water generally have a rounded and smoothed off appearance. Not always, but usually they do. And they're generally sorted into different layers. Remember, glaciers didn't sort material. Water does sort. So here's a question. Talks about which sample did the quartz grains undergo the most abrasion during erosional transport. So remember, the longer they're going to be abraded, the more sharp edges are going to be broken off, just like the lab you guys did. So we're looking for particles that are the most rounded. So not good, definitely not good. And so it's a toss-up between these two. And I would say that this is probably more spherical and rounded than these particles over here. So choice B would be the best solution. Sediments eroded by running water will be sorted. All materials are about the same size in this case. And so poorly sorted on the left, you see large particles mixed with small particles, all mixed up. This is not sorted very well. And as you move farther to the right, we have well-sorted particles over here. They're all about the same size and about the same shape. They're rounded, well-rounded. This is a type of sorting called vertical sorting. It happens in quiet water, which is water that is not moving. It's not flowing like down a stream or something. And so they settle according to, and you can see different factors here, size, the largest generally being the heaviest, and the smallest being the lightest. So they settle by size, by shape. Now this picture does not show it very well, but shape would mean that the particles that are flattest are going to have the most resistance when settling, and so they're going to end up on top, and the roundest particles would be on the bottom. So if that were the case, we could draw some flat particles in up here. I know they don't look very good, and the round ones would be all on the bottom. They have less resistance when settling through the water. Third factor, density. Now, I don't have any way to show that in this picture, but just imagine the particles on the bottom. If you dropped a handful of sediments into a tube of quiet water, the ones that are the most dense are the heaviest and would probably settle to the bottom much quicker than particles that are not quite as dense up on top. So density also is a big factor in terms of depositing sediments and sorting. So the bottom will contain sediments that are large, the heavy sinks faster, round, which is smooth and therefore flows through the water quicker, less resistance, and dense, which are also heavy. And we can actually do this in lab class. We are going to do a lab on deposition, which will involve lots and lots of water, stopwatches, and all kinds of fun stuff. Okay, moving on. Now, if you have multiple layers of vertical sorting, it becomes something we call graded bedding. And you can actually see the decreasing grain size upward through the bed, indicating deposition from a waning current. So perhaps this was a flood, and during the flood, the large particles were carried, and then the flood started slowing down, the water speed slows down, and the bigger particles deposit first, all the way across. And then, as the water speed slows even more, medium particles settle. And then over time, even smaller particles. And eventually you get down to the top layer here, or up to the top layer, and the smallest of all the particles settle. Now, this would actually be two events, different events in time. The first event perhaps could be one flood event, and the second another. Maybe this was a thunderstorm here, and this was a hurricane or something here, and some flooding from that. Or perhaps one was 1 year's spring melt-off, when lots of water, comes out into the streams from melting snow, and this could be another. It all depends on the area and the situation. Okay, this next slide shows on the left-hand side contour lines, which shows kind of towards the head of a stream to the mouth of a stream. Now, the head of the stream is going to be, the headwaters are going to be way up towards the beginning of it where the stream actually starts. And the mouth is going to be where the stream enters the ocean. And often at the mouth, you'll find sediments depositing in a fan shape, and we call that a delta, after the Greek letter delta. And here you can see the Mississippi River Delta, where it's depositing all this sediment out into the Gulf of Mexico. Now this velocity slows when entering a large body of water, and this creates something we're going to learn on the next slide called horizontal sorting. So we get vertical sorting and horizontal sorting. This occurs when sediments enter a body of water, and those sediments are carried in water that's now slowing down as it hits this larger body of water. And they're going to settle in terms of their size, from largest to smallest. So here we see our biggest sediments settling first, and then they get smaller. And as they get smaller, over time they might get buried and turned into sedimentary rocks. And you can get some sandstone here. Then under here, over long periods of time, you might see some siltstone forming as a rock. Clay would eventually form something like shale. And any precipitates, remember, these are things where the salts are just dissolved in high amounts in the seawater. They could form rocks like, perhaps gypsum or limestone. Now deltas, you're more familiar with. They form, of course, where rivers meet oceans or lakes. But there's another feature that looks similar to a delta called an alluvial fan. And they form when streams come out of mountains into canyons, where it's a much drier place. The velocity slows down during these flash flood events usually, and it forms a horizontally sorted kind of fan-shaped deposit, which we don't call a delta, we call an alluvial fan. So they look like deltas, but they're on land. They actually have a type of stream drainage patterns that we learned earlier in this unit. Remember back to the dendritic, and it's actually kind of a mixture of dendritic and a radial type, but we don't want to get confused with those terms in this. It's fan-shaped. And that is it. Nice quick lesson today.